All right, homework check time for section 3.5. I'm not going to be there in this class, so I wanted to record a video of me going over the homework. So I'm sure you have questions on this. First off, number 3, we have these two overlapping triangles here. We have PM. PM is this entire side. PM is congruent to RM. RM is this entire side here. Angle SPM, SPM, which is this angle right here, is congruent to angle ORM. ORM is this angle right there. We are trying to prove the triangle PSM. So I outlined PSM. You saw me do that in the lesson video notes. Outline PSM, and I pulled it off here to the right, and you'll see SPM has the arc with one tick mark there. I've marked PM as well with one tick mark, so I will erase what I have here. And then we'll get to this vertex angle at M here in a moment. We're trying to show that that triangle, PSM, is congruent to triangle ROM. So ROM is this triangle right here on the right side. I outlined it as well. You will see the angle at vertex R has an arc with one tick mark, meaning the angle at vertex P and the angle at vertex R, they're congruent. Again, that was in our given information. We were also given that RM is congruent to PM, so that is shown with the one tick mark. So I'll erase what I have over here from earlier. And notice at vertex M right here. At vertex M, this angle that shows up in both of these triangles, it's the same angle. So the angle at vertex M in PMS and the angle at vertex M in RMO, that's the same angle. So by the reflexive property, PMS has to be congruent to RMO. So let's get to it. First off, PM is congruent to RM. One tick mark, one tick mark. That's given. Angle SPM is congruent to angle ORM. Arc with one tick mark, arc with one tick mark. That's given. Angle SMP is congruent to OMR. That's the angle at vertex M for both of those. That is the reflexive property. And then you can tell once you uncouple these triangles using by drawing them separately off to the side here, you can easily see once you mark it up correctly that angle side angle is being satisfied here. So these two triangles must be congruent by the angle side angle congruency postulate. On to number 9. Number 9, all right, we have YW bisecting AX. All right, so here's YW right here, which means W is the midpoint of AX. So we have one tick mark here at AW, one tick mark here at WX. We also know that angle A, all right, there's angle A, arc with one tick mark, is congruent to angle X, arc with one tick mark right there. And we know that angle 5, well, here's angle 5, is congruent to angle 6, congruent to angle 6. I used an arc with 3 tick marks and arc with 3 tick marks. Now, what are we trying to show? We're trying to show that ZW is congruent to YW. Now, ZW is a side of triangle ZWX. ZW is a side of triangle ZWX. I notice right away I've got WX congruent to AW. I've got angle X congruent to angle A. So we've almost got some triangle congruency happening already. So what I did was I outlined ZWX, this triangle here, and I pulled it off to the side. And there you can see side ZW. Now, we're trying to prove that ZW is congruent to YW. So here's YW. It is a side of triangle AYW. AYW. YW is a side there. So again, I outlined AYW. I pulled it off to the side and I marked up the sides and the angles appropriately. So angle A, we were told, was congruent to angle X. You see that in the original figure as well. Also, we already talked about how AW is congruent to WX, congruent to WX. There you go. And notice I've got 3 tick marks here for angle 5, 3 tick marks here, and an arc for angle 6. But I've only got an arc and 2 tick marks here for AWY. Same thing for XWZ. There's a reason, and it's because angle 5 doesn't make up the entire angle of AWY. It makes up part of it, right? And angle 6 doesn't make up the entire angle for XWZ right here where my cursor is. It makes up part of it. But AWY, right here where my cursor is, AWY and XWZ, those two angles share angle ZWY. They share the same angle. So that angle ZWY makes up part of AWY and XWZ. So by the addition property, if an angle, meaning right here, ZWY, is added to congruent angles, angle 5 and angle 6, their sums must be congruent. So that is why AWY is congruent to XWZ. That is the addition property. If you're still not seeing that, that is from the last chapter. You need to go back and review that information. The addition property and subtraction property is still going to keep showing up in this lesson, or this chapter. So let's plow ahead then. Let's put this into a proof. Number one, YW bisects AX. That is given to us, which means AW is congruent to WX. AW is congruent to WX. By the way, the plan here is to show these two triangles are congruent, and then to use CPCTC to show that YW is congruent to ZW. Angle A is congruent to angle X. Angle A congruent to angle X. That is given. Angle 5 is congruent to angle 6. Angle 5 is congruent to angle 6. That is given. And then we can use 5 and 6 being congruent and the addition property to show that AWY, arc with two tick marks, is congruent to XWZ right here, arc with two tick marks. That's the addition property. Now we're able to prove these two triangles are congruent. Triangle AWY, make sure you're careful with your congruency statement. AWY is congruent to triangle XWZ. Make sure corresponding parts are in corresponding positions. They are with my congruency statement. That is the angle side angle congruency postulate. And then by CPCTC, ZW must be congruent to YW. That's number 9. On to number 12. All right, there's a lot going on here with number 12. First off, HO is congruent to MO. So let me zoom in here a bit. HO, 1 tick mark, is congruent to MO, 1 tick mark. Also, JO, I gave it 2 tick marks, is congruent to KO, 2 tick marks. We cannot assume that all 4 of these are congruent. We do not know that HO is congruent to JO. We don't know that MO is congruent to OK. All right, we don't know that. So we do have to use different tick marks to show that they might be different lengths. We also know that HJ, where's HJ? It's right here, is an altitude of triangle HJK, meaning we have a right angle right there. Also, MK is an altitude of triangle MKJ, so MKJ. MK is an altitude, meaning we have a right angle right there. What are we trying to show? We're trying to show that angle 1 is congruent to angle 2. Now, angle 1 and angle 2, angle 1 shows up in triangle MKJ. MKJ, angle 1 is one of those vertex angles. And angle 2 shows up in HJK. Angle 2 shows up in HJK. That is one of those vertex angles. So if I can show these two triangles are congruent, I can probably use CPCTC to show that those two angles are congruent. Now, those two angles are overlapping. So what I've done is I have pulled these two triangles off to the side here. So let me erase my right angles. You'll see why in a second. But here we have triangle HJK. I got my right angle in there. I got my 3 tick marks for JK. I also have triangle MKJ. Again, I got my right angle here at vertex K. I got 3 tick marks for JK. Why is JK congruent to JK? It's the reflexive property, right? Now, notice the hypotenuse of this triangle. HK, I've given it a circle, and MJ, I've given that a circle as well. Why is that? How do we know HK is congruent to MJ? We do know that at this point. Why do we know that, though? Look at HK. Look at HK. 1 tick mark, 2 tick marks. Look at MJ. 1 tick mark, 2 tick marks. By the addition property, we know that HK must be congruent to MJ. And now you're looking at these two triangles. You're like, oh, these look like they might be congruent, right? Well, side angle side's not satisfied. Angle side angle's not satisfied. And side side's not satisfied. So we don't know yet that these two triangles are congruent. But take a look over here at this figure. What do you notice about HOJ and MOK, those two triangles? We have a vertical angle occurring right here, don't we? All right, so if we have vertical angles occurring, we know that those two angles must be congruent. So triangle HOJ, which is this triangle right here on the left, must be congruent to triangle MOK, this triangle on the right. Now notice HJ, let me give this like a, I don't know, a triangle symbol or something. HJ must then be congruent to MK because of CPCTC, which means HJ must be congruent to MK over here as well. Now we know these two triangles are congruent. You could either use side, 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 or you could use side, angle, side, either way. And then we can use CPCTC to show that angle 1 is congruent to angle 2. Okay. So in the proof, I'm going to first prove that these two smaller triangles, HOJ and MOK, are congruent. So you see that here. Given that HO is congruent to MO, number 1, 1 tick mark and 1 tick mark. JO is congruent to KO, 2 tick marks, 2 tick marks. And angle HOJ, which is right here. Oh, come on, you. HOJ, which is right here, is congruent to MOK, which is right here. Vertical angles are congruent. We know that triangle HOJ is congruent to triangle MOK. That's a side angle side congruency postulate. Now, let's go ahead and start tackling triangle HJK and triangle MKJ. Remember, we need to show that HJ is congruent to MK, so let's do that now. We're going to build that from, we're going to conclude that from statement number 4. So statement number 5 is going to be HJ is congruent to MK. First and third, those must be congruent. Also, make sure you're careful when you write your congruency statements. How do we know HJ is congruent to MK? CPCTC. Alright, now let's go about proving that triangle HJK is congruent to triangle MJK. We've already shown that HJ is congruent to MK. We have to show these other congruent parts as well. Remember, we can use either side, 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 or side angle side. I think I'm going to go with side angle side. I'll use those right angles. That way I'm using my given information. So I'll go back to the given information. HJ is an altitude of triangle HJK. MK is an altitude of triangle MKJ. And that was given. Either couple these together or separate them, it doesn't really matter. So what does it tell us if we have an altitude? It tells us that we have a 90-degree angle. So let's write that in. So triangle HJK and triangle HKJ, HJK and, I'm sorry, I messed that up. Hang on one second. There we go, I got it fixed now. Angle HJK is a right angle, and angle MKJ is also a right angle. That is, what does that reason you think? Definition of altitude. Well, if we have two right angles, those right angles have to be congruent to each other. So how do we know that HJK is congruent to MKJ? All right angles are congruent. So there you go. HJK must be congruent to MKJ. All right angles are congruent. Let's then use the reflexive property. JK is congruent to JK. There you go. JK is congruent to JK. That is the reflexive property. And now we can use side angle side to show these two triangles are congruent. Be careful with your congruency statement. So triangle HJK must be congruent to triangle MKJ. That is the side angle side congruency postulate. Again, you could have also used side, side, side to show that HK is congruent to MJ. If you did that, you needed to use the addition property to show that HK and MJ are congruent, and then you wouldn't have used the given information in my statement number 6, and that is totally okay. But if you went that route, that's the way it should have worked. You would have left out the bit about the right angles being congruent and all that. Alright, well, if triangle HJK is congruent to triangle MKJ, we now know that angle 1 is congruent to angle 2 because corresponding parts of congruent triangles are congruent. There you go. All right, thanks very much for your attention.